The authority to present electrical training classes may be limited for certain establishments depending on state regulations. In many areas, only licensed or certified electrical instructors are permitted to provide formal electrical training. However, a retail store might be able to offer these classes within the scope of its retail operations. Concerns can arise about the class itself. Firstly, unqualified instructors may be presenting the information. If the instructors are store employees without proper electrical credentials, it raises serious questions about their knowledge and ability to provide safe instruction. Secondly, there may be inadequate responses to questions. Dismissive answers to what-if questions are a red flag. Experienced instructors should be able to address safety concerns and provide guidance on potential scenarios that can come up. Thirdly, potential code violations and safety hazards can arise. The instructor's omission of crucial information and failure to address potential violations could put participants at risk. If you are a certified instructor, there may be concerns about unfair competition. A store offering free classes by unqualified instructors can create unfair competition for a licensed electrical course provider. In addition, there may be reputation damage. If participants experience negative outcomes after attending the store's classes, it could reflect poorly on the electrical industry as a whole. Some recommended actions include contacting the local authority. Report concerns to the relevant authorities, such as the State Electrical Board or the Building Department. They can investigate the situation and take appropriate action. Another recommendation is to educate the store. Reach out to the store management and express concerns. Explain the importance of qualified instruction and adherence to safety regulations. It is also important to protect your reputation by continuing to provide high-quality electrical training and emphasize the value of obtaining proper certification. Electrical safety is paramount, and proper training is essential for anyone working with electrical systems. Always prioritize safety and seek guidance from qualified professionals. The National Electrical Code, or NEC, is a widely adopted standard for safe electrical installations. It provides comprehensive guidelines for electrical wiring, overcurrent protection, grounding, and equipment installation. Adherence to the NEC is crucial for preventing electrical hazards and ensuring the safety of people and property. Article 90. 1 of the NEC covers the purpose of the code, which is the practical safeguarding of persons and property from hazards arising from the use of electricity. Chapter 1 of the NEC covers general requirements, including definitions, wiring methods, and installation requirement. Chapter 2 covers wiring and protection, including requirements for overcurrent protection, grounding, and wiring methods. Chapter 3 covers wiring methods and materials, including requirements for raceways, cables, and conductors. Chapter 4 covers equipment for general use, including requirements for appliances, lighting fixtures, and motors. Chapter 5 covers special occupancies, including requirements for hazardous locations, healthcare facilities, and places of assembly. Chapter 6 covers special equipment, including requirements for elevators, electric signs, and X-ray equipment. Chapter 7 covers special conditions, including requirements for emergency systems, fire alarm systems, and data processing systems. Chapter 8 covers communications systems, including requirements for telephone systems, cable television systems, and network-powered broadband communications systems. And finally, Chapter 9 includes tables and examples to assist in applying the code. Understanding the NEC is essential for anyone involved in electrical work. It provides the necessary guidance for safe and compliant electrical installations. The NEC is updated every 3 years to reflect advancements in technology and address emerging safety concerns. Staying current with the latest edition of the NEC is crucial for electrical professionals. Electrical safety is a shared responsibility. By adhering to the NEC and promoting safe electrical practices, we can help prevent electrical accidents and protect lives. Grounding is another critical aspect of electrical safety. It provides a low impedance path for fault current to return to the source, tripping the overcurrent protective device and energizing the circuit. Proper grounding helps prevent electrical shock and equipment damage. Article 250 of the NEC covers grounding and bonding requirements. It specifies the methods for grounding electrical systems and equipment. Grounding electrode systems must be properly installed and maintained to ensure effective grounding. Grounding conductors must be sized appropriately based on the size of the circuit conductors. Bonding is the process of connecting metallic parts of an electrical system to create an electrically conductive path. Bonding helps to minimize voltage differences and prevent electrical shock. Bonding jumpers are used to connect different parts of an electrical system, such as metal conduits, equipment enclosures, and grounding electrodes. Proper grounding and bonding are essential for electrical safety. They help to protect people and equipment from electrical hazards. Overcurrent protection is another critical aspect of electrical safety. It protects electrical circuits from excessive current, which can cause overheating, fire, and equipment damage. Overcurrent protective devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when it exceeds a predetermined level. Article 240 of the NEC covers overcurrent protection requirements. It specifies the types of overcurrent protective devices that are permitted for different applications. Circuit breakers are resettable overcurrent protective devices that trip when the current exceeds their rating. Fuses are one-time overcurrent protective devices that melt and open the circuit when the current exceeds their rating. Overcurrent protective devices must be sized appropriately based on the ampacity of the circuit conductors. Proper overcurrent protection is essential for electrical safety. It helps to prevent electrical fires and protect equipment from damage. Wiring methods are another important consideration in electrical safety. The NEC specifies the types of wiring methods that are permitted for different applications. Wiring methods include rigid metal conduit, electrical metallic tubing, non-metallic conduit, and cable assemblies. Each wiring method has its own advantages and disadvantages, depending on the application. The NEC provides detailed requirements for the installation of each wiring method. Proper wiring methods are essential for electrical safety. They help to protect conductors from physical damage and environmental factors. The electrical equipment must be properly installed and maintained to ensure safe operation. The NEC provides detailed requirements for the installation of various types of electrical equipment, such as lighting fixtures, receptacles, and appliances. Electrical equipment must be listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories, or all. Listed and labeled equipment has been tested and found to comply with safety standards. Proper installation and maintenance of electrical equipment are essential for electrical safety. They help to prevent electrical hazards and ensure the equipment operates safely and reliably. Arc flash is a dangerous electrical phenomenon that can occur when a short circuit creates a high-energy discharge. Arc flash can cause severe burns, blindness, and even death. Article 110. The scene of the NEC requires that electrical equipment be marked with arc flash hazard warnings. Arc flash hazard warnings provide information about the potential hazards associated with arc flash and the personal protective equipment, or PPE, required to work safely on the equipment. Workers who may be exposed to arc flash hazards must be trained on arc flash safety procedures. Arc flash safety procedures include energizing equipment before working on it, wearing appropriate PPE, and using insulated tools. Proper arc flash safety practices are essential for protecting workers from the hazards of arc flash. Electrical safety is a complex and multifaceted topic. It requires a thorough understanding of the NEC, electrical principles, and safe work practices. By following the guidelines and recommendations outlined in this narration, you can help to ensure electrical safety in your home, workplace, and community. Remember, when in doubt, consult with a qualified electrician. Electricity is a powerful force, and it should be treated with respect. A qualified electrician has the knowledge and experience to safely install, maintain, and repair electrical systems. Never attempt to perform electrical work unless you are qualified and authorized to do so. Always follow safe work practices and use appropriate PPE. If you are unsure about anything, Ask for help. Electrical safety is everyone's responsibility. By working together, we can help to prevent electrical accidents and protect lives. Always be aware of your surroundings when working with electricity. Look for potential hazards such as damaged wiring, wet conditions, and exposed conductors. If you see a hazard, report it to the appropriate authority. Never take risks when working with electricity. If you are not sure about something, stop and ask for help. Electrical safety is not just about following rules and regulations. It is also about using common sense and making informed decisions. Always think before you act and never do anything that you know is unsafe. With proper training, knowledge, and safe work practices, you can work safely with electricity and protect yourself and others from electrical hazards. Remember to always verify that the power is off before working on any electrical circuits. Use a properly rated voltage tester to confirm that the circuit is energized. Never assume that the power is off, even if the switch is in the off position. Always test the circuit to be sure. When working on electrical equipment, always wear appropriate PPE, including safety glasses, gloves, and hearing protection. PPE will help to protect you from electrical shock, burns, and other injuries. Use insulated tools when working on electrical equipment. Insulated tools are designed to protect you from electrical shock. Never use tools that are not properly insulated. Keep your work area clean and free of clutter. A cluttered work area can create tripping hazards and make it difficult to work safely. Be aware of the location of emergency shut-off switches. In the event of an electrical accident, you need to be able to quickly shut off the power. Know the location of the nearest emergency shut-off switch and how to use it. If you are working on a circuit that is near water, take extra precautions to prevent electrical shock. Water is a good conductor of electricity, so it is important to keep water away from electrical circuits. Never touch electrical equipment with wet hands. If you see someone who has been shocked by electricity, do not touch them. Call for emergency assistance immediately. The person may still be energized, and you could be shocked if you touch them. Wait for qualified emergency personnel to arrive. When working with electricity, it is important to be aware of the potential hazards and to take precautions to protect yourself. By following these safety tips, you can help to prevent electrical accidents and injuries. Remember, electrical safety is everyone's responsibility. The ampacity of a conductor is the maximum amount of current in amps that a conductor can carry continuously without exceeding its temperature rating. The ampacity of a conductor is determined by several factors, including the size of the conductor, the type of insulation, the ambient temperature, and the number of conductors in a raceway or cable. The NEC provides tables that list the ampacities of conductors based on these factors. It is important to select conductors with the appropriate ampacity for the application to prevent overheating and potential fire hazards. Overloading a circuit can cause the conductors to overheat, which can damage the insulation and create a fire hazard. The NEC specifies the maximum allowable overcurrent protection for different types of circuits. It is important to install overcurrent protection that is sized appropriately for the circuit to prevent overloading. A short circuit is an unintended connection between two conductors of different potential. Short circuits can cause a large amount of current to flow, which can damage equipment and create a fire hazard. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current in the event of a short circuit. A ground fault is an unintended connection between a conductor and ground. Ground faults can cause electrical shock and equipment damage. Ground fault circuit interrupters, or GFCIs, are designed to detect ground faults and interrupt the flow of current to prevent electrical shock. GFCIs are required in many locations such as bathrooms, kitchens, and outdoor areas. Surge protection devices, or SPDs, are designed to protect electrical equipment from voltage surges. Voltage surges can be caused by lightning strikes, power outages, and other events. SPD divert the surge current to ground, protecting the equipment from damage. Electrical panels are used to distribute electricity throughout a building. The electrical panels contain circuit breakers or fuses that protect the circuits from overcurrent. Electrical panels must be properly installed and maintained to ensure safe operation. Electrical boxes are used to enclose electrical connections. Electrical boxes protect the connections from damage and prevent accidental contact with live wires. Electrical boxes must be properly installed and grounded. Conduits are used to protect electrical wires from damage. Conduits can be made of metal or plastic. Conduits must be properly installed and supported. Cables are used to transmit electrical power and signals. Cables consist of two or more conductors insulated from each other. Cables must be properly supported and protected from damage. Receptacles are used to provide a convenient point of connection for electrical appliances and equipment. Receptacles must be properly grounded and protected by a GFCI in certain locations. Switches are used to control the flow of electricity to lights and other equipment. Switches must be properly installed and rated for the application. Lighting fixtures are used to provide illumination. Lighting fixtures must be properly installed and grounded. Appliances are electrical devices that perform specific functions. Appliances must be properly installed and grounded. Motors are used to convert electrical energy into mechanical energy. Motors must be properly installed and protected from overload. Transformers are used to change the voltage of electrical power. Transformers must be properly installed and protected from overcurrent. Generators are used to produce electrical power. Generators must be properly installed and grounded. Batteries are used to store electrical energy. Batteries must be properly installed and protected from overcharge. Solar panels are used to convert sunlight into electrical energy. Solar panels must be properly installed and grounded. Wind turbines are used to convert wind energy into electrical energy. Wind turbines must be properly installed and grounded. The NEC provides detailed requirements for the installation of all types of electrical equipment. It is important to follow the NEC to ensure safe and compliant electrical installations. Always consult with a qualified electrician if you have any questions about electrical safety. Electricity is a powerful force, and it should be treated with respect. Never attempt to perform electrical work unless you are qualified and authorized to do so. Always follow safe work practices and use appropriate PPE. If you are unsure about anything, ask for help. Electrical safety is everyone's responsibility. By working together, we can help to prevent electrical accidents and protect lives. Article 100 of the NEC contains definitions of terms used throughout the code. These definitions are essential for understanding and applying the NEC correctly. Some important definitions include ampacity, bonding, circuit breaker, conductor, ground fault, overcurrent, receptacle, and switch. Understanding these definitions is crucial for anyone involved in electrical work. The NEC is a complex and comprehensive document. It is important to study the NEC carefully and to stay up to date on the latest changes. The NEC is updated every 3 years to reflect advancements in technology and address emerging safety concerns. Staying current with the latest edition of the NEC is crucial for electrical professionals. Electrical safety is a shared responsibility. By adhering to the NEC and promoting safe electrical practices, we can help prevent electrical accidents and protect lives. Remember, when in doubt, consult with a qualified electrician. Electricity is a powerful force, and it should be treated with respect. A qualified electrician has the knowledge and experience to safely install, maintain, and repair electrical systems. Never attempt to perform electrical work unless you are qualified and authorized to do so. Always follow safe work practices and use appropriate PPE. If you are unsure about anything, ask for help. Electrical safety is everyone's responsibility.